Good morning, students. Today we're going to be talking about minerals, rocks, and soil. As you can see here, we have some pictures of some minerals, rocks, and soil. So this topic is very important for you to learn about because this is what makes up the earth around us. So the past few weeks, we've been talking about plate tectonics. We've been talking about the layers of the earth. If you remember the mantle, we talked about landforms, things like plateaus and mountains and plains. We talked about earthquakes. We talked about tsunamis, the different natural disasters. Well, now we're going to actually talk about what the earth is made up of. So as you can see, minerals, rocks, and soil, we have examples here from a cave. We're going to zoom down. We're going to skip the introduction for now. Go straight to the meat of the content. First things first, we need to talk about elements and minerals. Elements are what make up everything. They make up everything that's living and non-living. There are about 118 elements currently known to man. This table shows you those elements. Now, we're not really going to get into the table because that's not something we cover at a 4th grade level. This is more high school chemistry. It is important to know, though, that each element is made up of individual atoms. So we have these itty-bitty, teeny tiny building blocks of life, of the world around you. And you get a whole bunch of the same type together, and that's what makes these elements. You have hydrogen, you have helium, you have carbon, oxygen. Hopefully you've heard of oxygen before because that's what we need to breathe in. All right, and if you combine carbon and oxygen, you get carbon dioxide. You combine hydrogen and oxygen, you get water. Then there's fluoride, there's neon, there's silver, there's gold, there's so many different ones. But like I said, we're not going to focus so much on the individual elements. You just need to know that elements make up minerals, make up rocks, and elements make up everything pretty much. So atoms, really this little chart here should say, and I'm going to write it in myself, atoms make up elements, which make up minerals, which make up rocks. All right, so we've talked about atoms, we've talked about elements. Now we're going to be talking about minerals. A mineral is made up of elements. All right, some minerals are made up of only one element. So this silver right here, this piece of silver is just made of silver. Iron is only made of iron, but many other minerals are made of 2 or more elements. For example, quartz is made up of silicon and oxygen. So they can be made up of one thing or they can be made up of a bunch of things. But remember, they're only made up of this combination of these elements. So you have these 118 elements, and they make up the almost 4,000 different minerals on our planet. And each mineral has its own mix of elements, so no two are the same. Now, all minerals are solids. That means they have definite shape, like a table. They have a definite mass. All right, they don't change. They're not like a liquid. They don't melt and flow. They're not a gas. Doesn't have shape. All right, so they're solid, like a tabletop. In fact, some of them make up tabletops. They form in patterns called crystals. All right, so different patterns make different crystal shapes. Minerals are also inorganic. That means they were never alive, ever. Minerals are made up of non-living things. Non-living means inorganic. All right. So crystals are the pattern of crystals are what makes up minerals. Something important to remember. I'm just going to erase the atoms here. They don't need to come along for the ride. All right. Now, rocks. A rock is a hard, solid material. It is found in nature, and most rocks are made of different minerals. So you have minerals, which are made of one or more elements, and then you have a rock, which is made up of different minerals. Hopefully, I am repeating this a lot, so hopefully you're starting to understand this is the important part of the concept. All right, now we're going to look at a rock. See, here's a rock right down here. It might have many colors and patterns. There are the bits and pieces of different minerals. The mix of minerals in one kind of rock help you tell it apart from other kinds of rocks. So just like how each mineral has its own unique set of elements, rocks have their own unique set of minerals in the way they're combined. All right? So this mixture of minerals is not the same as another rock of a different type. So all the rocks of the same type have the same kind of mixture. Those of different types have different types of mixture of minerals. So once again, elements make up minerals, make up rocks. So knowing that each rock has its own unique way of being made up of minerals, that can help you describe it, compare it to other rocks, and even identify it. So you can describe and compare rocks in many different ways. Now we're going to look at this chart here that shows you how to describe and compare rocks. So you can obviously, like we've been talking about, what minerals it's made out of. Composition means what it's made out of. So some rocks have a special mixture of one or more minerals. You can talk about their size, if they're huge boulders or small pebbles, mountain size, dust size. Size is important. Shape. They can be flat, round, square, any shape you can imagine. Humans can cut them. Nature cuts them. We're going to talk about that with weathering and erosion in a minute. So you can talk about what shape they are. Color. Believe it or not every single rock in the world is gray. There are many different colors. It all depends on what minerals they have inside of them. All right. Texture. So some rocks, if you've ever picked up a rock, you might have felt it was really smooth, or it might have been really jagged and it almost hurt your hand to rub it across the top. They can have tiny grains, large, smooth chunks, long, pointed crystals. Some of them even have air holes inside of them. Hardness. The Mott's hardness scale compares how hard each mineral is within a rock. So talc is 1, very soft. You can cut it with your fingernail. You can draw all over it with your fingernail. Diamonds are rated a 10, very hard, and they're actually one of the hardest substances on the planet Earth. In fact, one of the few things that can cut diamonds are other diamonds. That's why they even make synthetic or fake diamonds, because they're so hard that they're used in industrial machines. They're used for the big, big machines used to cut other stuff. And, of course, location. A beach will have different rocks than a forest, than a desert, than a volcano. So you want to know where in nature the rock is naturally found. Not where it was moved to by humans, but where it is naturally found. So those are the different ways that you can describe and compare rocks. Next, rock groups. Yes, we have different rock groups, and no, I'm not talking about a band. I'm talking about different groups of the actual rocks. All right, so they are placed into groups. These groups tell us how the rocks are formed. There are 3 major kinds of rock groups, so we're going to look at each of those groups now. Igneous rocks. I think we talked about this a little bit when we talked about volcanoes. So boom, volcano blasts hot liquid rock from beneath the Earth's crust. You should know that the liquid rock underneath the surface is called magma. When it comes up and comes out onto the surface of the planet, when the volcano erupts, it is called lava. This lava, this magma, when it cools down, it creates igneous rocks. So to remember how an igneous rock forms, think of the word ignite. It means to start a fire. Igneous rocks start off very hot and then cool down. So igneous volcano, igneous volcanoes, igneous volcanoes. If you can remember that volcanoes have magma and lava, and that igneous rocks are formed by volcanoes, by that magma and lava, you'll be good. All right, so the crystals in igneous rocks are different sizes. So if the lava cools really quickly, once it gets to the surface, if it cools down really quickly, the crystals don't really grow. There's no time for them to grow, so they're small. For example, this pumice rock right here has a bunch of little air holes in it and can even float in water. Yes, there are rocks that can float in water. Now, though, when the magma cools slowly, is time for the crystals to grow. So granite's an example of that. If you look at granite, you can actually see some of the crystals in the pattern. So granite is hard and very solid. It's used for kitchen counters and in the walls of some buildings. And then we have obsidian. I don't know if you've ever seen this. It's very black. It almost looks like glass. It's cool. It's formed when magma cools extremely quickly. Like, gets out, the lava comes out and cools just like that. It doesn't stay in as a liquid almost at all. So it looks like black glass is used a lot in like jewelry or artsy, fancy type stuff. Like decorations, that's the word I'm looking for. All right, moving on. Sedimentary rocks. Some rocks are made of tiny bits of minerals called sediment. You might remember the word sediment from when we talked about weathering and erosion. Because remember, weathering breaks down that rock into sediments, and erosion carries those sediments somewhere else, and then they are deposited in that new place in the process of deposition. See, all of this stuff comes back. It's like a cycle. Everything builds on each other. So, sediments are so small that water and wind can move it, and they also build up in layers. So the older layers at the bottom are pressed together. Newer layers build up above them. Over a long period of time, weight and pressure make sedimentary rocks. So think about it this way. Let's say you had a piece of paper, and I'm going to draw this. You know when you have a piece of paper and it's kind of crumbled like that? And then you might put a book on top of it. You know, if it's sitting on, let's say it's sitting on a table, and then you put another book on top of that, and another book on top of that. What's going to happen? Well, eventually that paper down there is going to flatten out. I'm going to redraw that. All right, and it's going to become flat, right? Now imagine, so we know that pressure can change things. The pressure of the books squishing down on that paper can make it flatter. Now imagine you had two pieces of paper that were crumbly, and you put glue between the two of them. Now, if you just sit them on top of each other, nothing's going to happen, right? But if you start applying pressure, if you put these books, or if you put your hands on top of them, and you squish them together, what's going to happen? They're going to stick together, right? So that's what we talk about with pressure. When we talk about the weight and the pressure make sedimentary rocks. Basically, the weight of all the new layers of sediment pushes on top of the old layers, pushes really, really, really hard to the point where they're all squished together. And the water is squished out of them, and they're squished together, and they become a piece of rock. All right, breccia is a type of sedimentary rock. Now, some sedimentary rocks, I'm just going to erase this little image here so it doesn't keep following us. Some sedimentary rocks, such as sandstone, are easy to break. Some are strong, so it all depends on the rock. As you can see, it also tends to look like it's in layers. If you've ever seen a picture of the Painted Desert, I believe it's called, if you look at the rocks, they look like the colors come in layers, like in bands. Like someone took a big paintbrush and just painted stripes. All right, that's because each one of these layers is a different sedimentary rock. Now, fossils may be found in sedimentary rocks. Millions of years ago, dead plants and animals settled to the bottom of the lake, rivers, and seas, and over time, the layers of sediment buried the plants and animals. As rocks formed, a leaf or animal might have become part of the rock that left a mark in it. All right, so if you think about it, going back to our book explanation. So we have, these two pieces of paper, they're a little crumbled, and we put some glue in between them, and we also put, I don't know, we're going to put a piece of construction paper, a piece of blue construction paper. And then they're sitting on the table. In this case, the table would be the Earth's crust, what makes up right? We talked about that. What makes up the the land or the seafloor, depending on what we're talking about. And then we have all these new layers represented by these books. They're going to go down and they're going to squish it together. And when this gets squished together, we're going to pretend that these get squished together. They're going to be squished together. That piece of blue construction paper is going to be caught right in there. That's kind of what happens with the layers of sediment when they bury the plants and the animals. Think of that blue piece of paper like a plant. It's going to get squished in there, and so it's going to get stuck in there. And eventually, that's how the fossils are formed. Because eventually, someday, someone will take away all these top layers, whether it's humans cutting up the land or it's something natural, erosion, weathering and erosion. Something's going to happen and it's going to expose this top part here, going to take off this top layer, and it's going to leave behind just that blue piece and the rock underneath it. That's a fossil. All right. Hopefully that makes sense. Okay, so you look for fossils where oceans, lakes, or rivers used to be. Fossils can give clues about the plants and animals that once lived there. That's how we know a lot about history before there was written word, before people were able to write. Did you know coal is a sedimentary rock that is mostly made of the element carbon? Carbon is found in living materials. So over millions of years, pressure turned the living materials into rock. So all of the plant debris, from the dinosaurs even, it all got squished, and that carbon was squished into a rock. Millions of years, guys. All right, so if you drop a rock on your foot, it's not going to turn into coal. I promise. So this takes millions and millions of years, and that's why people are so worried about using up all the coal on the planet, because we can't really make more very easily, and it takes millions of years for it to form. All right, moving on. Metamorphic rocks. Metamorphic rocks form when heat and pressure change older rocks. So basically, you take an igneous or a sedimentary rock, or even a different metamorphic rock, you squish it, you heat it up, and you get a new metamorphic rock. So all three kinds of rocks can end up deep below the Earth's surface. Remember when we talked about how old crust was formed? How one tectonic plate can be pushed under another and pushed back into the mantle and melted? That's what we're talking about here. All right, so once it's there below the Earth's surface, back in the mantle, back towards the mantle, once there, the heat and pressure can change them from one rock group to another. So, for example, a soft sedimentary rock can become a hard metamorphic rock. Now, metamorphic seems like a really big word. And this is phyllite and gneiss, which are two metamorphic rocks. But it really just comes from the word metamorphic really just comes from the Greek word metamorphosis, which means to change. We talk about metamorphosis, and you might have talked about this before, I'm not sure. But we usually talk about a metamorphosis when we're talking about butterflies. The metamorphosis is when the caterpillar becomes a chrysalis becomes a butterfly. So I know metamorphic might seem like a big word, but it really just is a fancy way to say change. It's a fancy Greek way to say change. All right. Moving on, the rock cycle. Rocks go through a rock cycle. Whoa, wait. What, you mean you just put them in the washer? Like, there's the rinse cycle, the wash cycle, the rock cycle? No. See, once a rock is made, it doesn't stay as that rock forever. Any rock you can find outside was not always that rock. If I picked up a piece of gold, it was not always in that form. If I pick up a random rock outside on the playground, did not always look like that. Strong rocks can be broken up, weathering and erosion, and be pressed together again. A weak sedimentary rock can be heated and placed under pressure, and it can change and become a metamorphic rock, like marble. Marble, which is, of course, used to make buildings and statues. So we're going to look at this diagram really quick to see how rocks change from one type to another. This is what's called the rock cycle. It's how one rock can go between all three types of rock. So let's say we start out with this lovely igneous rock here. This is obsidian, remember? And through weathering and erosion, we take off tiny little sediments from it. Remember, that's the tiny little broken down pieces. And those tiny little pieces are pushed together and make sedimentary rock. And then the sedimentary rock is pushed underneath the surface of the earth and with heat and pressure is made into a metamorphic rock. And then it's melted. It's melted and it's made and it goes back into being magma, and then it comes lava, and then it cools on the earth's surface, and then it becomes igneous rock again. Then it gets pushed back under and it becomes a metamorphic rock again because of that heat and pressure after it's pushed back into towards the crust. And then that metamorphic rock, weathering and erosion, wear it down in little pieces and then it's squished together into sedimentary rock. And then that sedimentary rock becomes part of that magma and lava again, and magma, lava, and then cools to an igneous rock. This is happening all the time, guys. So any rock you see, it's not going to stay that way forever. Eventually, over years and years and years, it will change. All right, weathering and erosion. This part of the chapter should be familiar. Rocks can change in shape or size. They can also move from one place to another. Weathering breaks down rocks, changes their shape and their size. Moving water, wind, can make rocks smooth and round or break it into pieces, just like when you sand something, it makes it smoother. Well, wind and water can basically sand or make those rocks smoother, break it up. Water can seep into cracks in the rock and freeze. And then ice, because it is bigger than water. Think about it. If you've ever seen an ice cube, when it melts, it seems like there's less water. That's just because ice expands when it gets cold. It's one of the few substances to do that, FYI. So water seeps into a crack in the rock, freezes, the ice gets bigger. All right, so like for example, so this is our rock. This is our little crack. This is our water. It goes in like during the rain, and then during the winter, like the winters in New York, where it gets really cold, the ice expands, gets bigger, and it makes that hole bigger. As you can see, look, now the hole is much bigger. That crack is much bigger. That will eventually break up the rock. All right. Plants' roots can grow into a crack in a rock and break off pieces, just like you can see this rock here. That's called mechanical weathering, when something kind of gets in the rock and breaks it up, whether it be ice, plants, etc. Chemicals in rocks can also change too. Minerals such as salt fall apart or dissolve when mixed with water or chemicals. So sometimes there's a mineral in the rock that is dissolved or falls apart because of something in the environment, and that's called chemical weathering. Acid rain that has acid in it, can change the minerals for example, on this gravestone. This is chemical weathering. Don't really worry about mechanical and chemical weathering. Just know that weathering breaks down rock. Okay? Sounds good. Erosion. So this architecture is called by weathering. Rockside caused by erosion, because erosion moves those rocks. So wind and water move loose pieces of rock or sediment from one place to another. As some rocks move, they create more erosion by making other rocks move. This moving and bumping can cause large boulders to break into smaller rocks. A big rock can become stone, pebbles, sand, or even dust. There's also other forces that cause erosion. Glacier. Big piece of ice that's slowly moving, usually has rocks stuck in it on the bottom where it's touching the ground. It carries those rocks, and not only that, but it makes those rocks run into other rocks and breaks them up even more. Earthquakes. Heavy rain can cause landslides. All right, those rocks move when that landslide happens. Gravity. Good friend gravity makes those loose rocks tumble down the mountain. All right, now we're moving on to soil. Well, you might say, Miss Brown, I know what soil is. I go outside and play in the dirt all the time. Well, we're going to talk about it a little bit differently than you might be used to. So Earth's land has rocks and minerals. It also has what's called organic matter. That's you, me, your pets, my pets, plants, animals. That's everything that's everything that's alive, or everything that was once alive. All right, and that means like even after a tree dies, it's considered organic. So this organic matter is made up of rotting plants, dead animals, and animal waste. Soil is a mixture of rocks, minerals, and this organic matter. It also contains air and water. So you take rocks and minerals, you add organic matter. This is compost, it's food trash. Remember, this all was alive at one point. Yes, plants are alive. And you combine it into soil. Now, the organic matter in soil is called humus. It is full of nutrients. Plants need nutrients to grow and to live. Many animals, including people, use those plants for food. All right, now there are different kinds of soil around the world. It has its own mix of minerals, rocks, and humus, or that organic matter. All right, and it takes many, many years for each soil mixture to form. Now, it comes in many colors and textures. Some are dense, it's packed together really tightly. Other soils aren't so tight, and it's easier for like you to kick it and kind of spread the soil around. All right. You can see over here we have some pictures of some different types of soil. Some are better for growing things. Some are better for water, to move through, things like that. There's over 10,000 kinds of soil just in Europe. So it's not like the dirt here is the same as the dirt in New York, is the same as the dirt in London, is the same as dirt in China. It's all different. Now, like rocks, soil can change and move. It changes most near the surface. So soil often has different layers. The thin layer on most of Earth's land is called topsoil. This is the soft part. It's got the humus, or the organic matter. It has more air and water as well. This is where your plants are going to be putting their roots. Then you have the subsoil. It's drier, harder, has more rocks. Not quite as good for growing stuff. And then there's bedrock. It's pretty much just rock at this point. It's very hard, very dry. Not a whole lot of actual like sand or anything besides the rock. Now, one way we describe soil is by its texture. Think about sand. It feels gritty if you've ever picked up sand. Silt is even smaller. It almost feels like a flower or something. Clay is made of even smaller bits mixed with water. It's kind of sticky, almost like Play-Doh. Loam is a mixture of all of this plus that organic matter. And unfortunately, we're losing this topsoil layer because of human actions. This is what this is talking about. Last 200 years, the United States has lost a lot of its topsoil due to farming, logging, and grazing, either human activities or what we allow our animals to do. So with fewer plants in the soil, wind and water cause more erosion. Soil washes down rivers and into streams, then eventually, down to the ocean. So this is bad, because remember, this is what we need to grow crops in. So we need to try to protect our topsoil. All right, using Earth's resources. We're almost done, guys. Hang in with me. When we use rocks, minerals, and soils, we call them resources. Some resources are deep below Earth's surface. All right, these are our natural resources, which was a social studies term. People mine, dig, drill, or blast into the land to reach them. All right, so we try to get them out any way we can. Most of Earth's resources have to be processed so we can use them. So most metals are found inside rocky ore. The machines remove the valuable metals from the ore. Other resources are burned to move vehicles and heat homes. These are called energy resources. That's your coal that we were talking about earlier. All right, really quick conclusion. Elements make up minerals. Minerals make up rocks. Rocks may be igneous, sedimentary, or metamorphic. Over time, each kind of rock can change in any other kind of rock. Weathering and erosion change and move rocks. Bits of rocks mix with organic matter to form soil. Earth has countless kinds of rocks and soil. People use Earth's resources to make things and grow food. Some resources are in limited supply. This is important. So it's important to use Earth's materials wisely. We can run out of things, like coal. So we need to be smart about how we use our resources. Hint, hint for the group that is doing the vocabulary term resources. All right, glossary. I am not going to read through all of these, but instead, I'm going to see if I can. I'm going to move the tool, and I'm going to hopefully move this. Actually, let's see if I can actually. Okay, there we go. I'm going to zoom out a little bit. So that way we can hopefully fit all of the words on the page. And this is a good place to pause and look at vocabulary, whether it's in class when we're doing our vocabulary worksheets or at home if you're studying for a test. And this is a hint to, whoever's running the video in the classroom that it's time to pause the video. All right. So that is minerals, rocks, and soils for you, ladies and gentlemen. Join us next time we talk about another wonderful earth science topic.